In this lesson, we're going to look at examples that you may see as part of your worksheet or My Math Lab that wasn't in a previous lesson. But even with the previous lesson, you could still do the problems that look like this. But before we go on, keep in mind that in previous lessons we talked about perfect squares. So let's kind of review that idea again, perfect square. And so remember your perfect squares are 1, 4. So these are your perfect squares. 1, 4. The next one is 9 because remember 3 squared is 9. And the reason and for 4 we said 2 squared, 1 squared. So we're just taking all these whole numbers and we're squaring them. And so the next one is 4 squared, which is 16, and so on. Okay? And so when we took the square root of these perfect squares, we got this base that you saw here. We got that number that we squared. So for example, the square root of, let's say 25 is equal to 5 because 5 squared equals 25. All right. Now keep in mind that when you see something like this, we're looking at the principal square root. So that's the principal square root. Remember, use the word principal, P-R-I-N-C-I-P-A-L, principal square root. So remember in the previous lesson, the principal square root was the positive square root. Positive square root. So if you're asked to find the principal square root of, let's say, 36, then the answer is just 6. So the answer is 6. Answer is 6, only 6. So the principal square root is a positive square root. So basically you're taking the square root of 36. Now if you're told to find all square roots of 36, then the answer would be positive 6 and negative 6. Because when you have to find all square roots of 36, you're basically finding the positive and the negative square root of 36. So you're finding the principal square root of 36, which is 6, and you're finding the negative square root of 36, which is negative 6. Okay? All right, so that was kind of some things that you've learned in a previous lesson. What we want to do here, though, is we want to simplify each of the following. So, for example, number 1, suppose we had 5 times the square root of 9. So don't let that confuse you. What you may want to do is basically cover up that 5 for right now and then think about the square root of 9. Well, we know that the square root of 9 is 3. And so when we read this as 5 times the square root of 9. So that becomes 5 times 3, which is 15. So the answer is 15. All right. Number 2, suppose we had a negative 2 times the square root of 25. We'll do the same thing. So first of all, look at the square root of 25. I can simplify the square root of 25 because 25 is a perfect square. And the square root of 25 is 5. And so this becomes negative 2 times 5, which is negative 10. And number 3, we have the square root of 81 plus the square root of 16. All right, so now we're adding these two square roots. But each of those, if you look at the radicand, 81 is a perfect square, 16 is a perfect square. So that's not a difficult item to deal with. So the square root of 81 we know is 9 plus, because 9 times 9 is 81. And the square root of 16 we know is 4 because 4 times 4 is 16. And so when I add those up, 9 plus 4 is 13. All right. Number 4, we have 7 times the square root of 121 minus 4 times the square root of 144. All right, so 7 times the square root of 121 minus 4 times the square root of 144. All right, same thing. So don't make this complicated. So if you cover up these parts here, the square root of 121 is a perfect square. The square root of 121 is 11. And 144 is a perfect square, and 12 times 12 is 144. So the square root of 144 is 12. And so this becomes 7 times 11 minus 4 times 12. And then use your calculator if you need to. 7 times 11 is 77. subtract, and then 4 times 12, that's going to be 48. And then 77 minus 48, so 77 minus 48 will give you 29. All right, so that's number 4. Now let's look at one more. And so let's look at this problem. Suppose we had 2/3 times the square root of, and let's say 81 minus, and then let's say 1/4 times the square root of 25. Okay, and let's see how to deal with that. So we have fractions, no big deal. You have enough experience dealing with fractions in the past to get through this. So the same thing, if you cover up the 2/3 and you look at square root of 81, the square root of 81 is 9. So this becomes 2/3 times 9, minus, and then 1/4, and the square root of 25, if you look at this part here, the square root of 25 is 5, so it becomes 1/4 times 5. So now notice you have two products here, and you're subtracting those. So remember, order of operation, you got to multiply first. You have to multiply first and then subtract. But let me go ahead and rewrite this over so I can reduce. So I can reduce here. 3 into 3 is 1. 3 into 9 is 3. So I get 2 over 1 is 2 times 3, which is 6. Minus, now I can't reduce here, so 1/4 times 5, and if you need to rewrite 5 as 5 over 1, then do that. 1 times 5 is 5, 4 times 1 is 4, so I get 5/4. And then 6 minus 5/4. Now you want to rewrite this as one fraction, by the way, and don't use a decimal. You didn't see any decimals involved here, so don't use a decimal. Leave it as a fraction. So you may need to go off to the side and do some work here. So the LCD is 4. So you're going to write two fractions with that denominator. So remember 6, let me go ahead and do this right here. So 6 over 1 minus 5 over 4. So I have 1, I want to rewrite an equivalent fraction for 6 using the denominator of 4. So if you think about it, 24, so 24 divided by 4 is 6, right? 24 divided by 4 is 6. So those two fractions are equivalent because 24 divided by 4 is 6. Now, do you remember how we did this? So remember, we have 1 here, we want to get 4. So I got to multiply the denominator by 4. What I do to the denominator, I do to the numerator. And so 6 times 4 is 24. That's a 4. And then notice that these denominators are the same, so that means that 5/4 is equivalent to itself. And if you need to multiply by something, 4 times 1 is 4. 5 times 1 is 5. And so now this becomes 24 minus 5/4, which is 19/4. All right, so that becomes 19/4. Or if you want to write as a mixed number, so remember 4 into 19. 4 into 19 is 4. 4 times 4 is 16 with a remainder of 3. So we get 4 and 3/4. 4 and 3/4. So that's how you would do this. Now, just remind yourselves about the calculator. So if you use a calculator, so you have 6 minus 5/4, right? So you're going to say in your calculator, you're going to say 6 subtract 5 divided by 4, and you get this decimal. Now, most of you know, or all of you know that when you read this as 4 and 75/100. Well, remember, 75/100 reduced is 3/4. So notice 4 and 3/4. Okay. Now, some of you may want to go a little bit further. You may want to say, well, I want to use my calculator to convert that to a mixed number. So let's go ahead and do that. So you're going to press second right here and this button here. Oops, sorry, wrong button. Excuse me. So we had 19 divided by 4. All right, so we had this. You can press second, this button here. So you see where it says FDDF right here? And then I'm going to convert it, press equal, you get 4 and 3/4, which is what this is. And then as a mixed number, so you have this mixed number, and so as an improper fraction, you say 4 times 4 is 16, 16 plus 3 is 19, so you get 19/4. Okay? So just make sure you know how to use your calculator. And so that is all I wanted to do there. So there are some problems where you are going to be seeing situations like this. All right, so that's the end of this lesson dealing with square roots.